In this section we're going to look at basicity of amines. So basicity is their ability to act as a base, really important chemical property of amines, and they would often be regarded as the organic base, so the opposite of our acids, carboxylic acids in the organic world. What allows amines to act as a base? Well, of course, it's the lone pair on the nitrogen which is able to accept a proton. What we're going to be looking at are the things that might be attached to the nitrogen and how this will affect the base strength of the amine. So what possible things might be attached to the nitrogen? Well, it might be that we've got a hydrogen there. It might be that we've got an alkyl chain, so a couple of carbons, or that alkyl group might be aromatic, so we might have a benzene ring. And these three different things will affect the basicity of the amine. So let's look at alkyl groups. So in this case I've attached a propyl group to the nitrogen. So how does this affect the basicity? So I suppose what we need to think about for the basicity is the availability of the lone pair. So the more available the lone pair, the stronger the base. So does the alkyl group withdraw the lone pair, or does it enhance the lone pair? Well, the alkyl group has an electron releasing effect, as in the positive inductive effect. So electrons are drawn from the alkyl group towards the nitrogen, and this will make the lone pair more available, more prominent. So adding alkyl groups onto the nitrogen will increase the base strength of the amine. So if we compare these two amines, on the left hand side we can see we've got a primary amine which has just one alkyl group attached to it. This will release electrons towards the nitrogen, but on the right hand side we have three alkyl groups attached to the nitrogen. So this is a tertiary amine, so more alkyl groups releasing their electrons, which makes the lone pair on the nitrogen far more prominent, far more available to accept protons. So tertiary is a much stronger base in this example than the primary. We'll now look at an aromatic being attached to the amine. So I've just put a benzene ring on the nitrogen now. We might not know too much about benzene rings, but if you think of a benzene ring as a little whirlpool of electrons, then we might imagine that, like with an alkyl group, this will increase the electron density on the lone pair, but to the contrary, now electron density is withdrawn from nitrogen towards the benzene ring. So this makes the lone pair on the nitrogen less available and decreases the base strength. In fact, if we make a comparison now with these three compounds, all, yes, able to act as a base, so they've all got the lone pair on the nitrogen. So let's have a look for the things which are going to affect the base strength. Here, the first example, of course, is our old friend ammonia. So this has neither alkyl groups nor aromatics. The second example, we've got phenylamine with the benzene ring attached, and we know that this withdraws electron density from the nitrogen And the final example, ethylamine, and this has the alkyl group, which we know releases electron density towards the nitrogen. So their impact on the availability of the lone pair, well, if we show this with a little envelope around the lone pair, so we've got ammonia minding its own business. The availability of the lone pair in phenylamine is less than that of ammonia, but in ethylamine's case it's going to be greater than ammonia. So if we had to rank these in terms of their base strength, we've got ethylamine as number 1, ammonia will be at number 2, and phenylamine is the weakest out of these 3 bases.